So, common core standard we're learning today is the law of sines. Okay. Now, on the law of sines, you absolutely need a pair of opposites. We're going to make ourselves a little note for the law of sines. You absolutely need a pair of opposites. Okay. But before we do that, we're going to find the area of a triangle. So, normally the area of a triangle is 1/2 base times height, but there's no height, is there? So we got this other form that helps us, okay? Normally you got to have a base and a height. But if you happen to know the two sides and the angle, remember side, angle, side from geometry? If you know side, angle, side, then you can find the area. You have to have the two adjacent sides and the angle to find the area. So it's as easy as this. It's just going to be 1/2 adjacent times the sine of theta. It does not matter which one you call adjacent 1, adjacent 2, okay? Because you're just multiplying. So this or this could be the first adjacent. Does not matter. So to find the angle, to find the area, you're just going to go 1/2 this side times the sine of the angle, right? So let's take a look at example 1. We're going to set it up. We're just going to go area is equal to 1/2 12 times 8 times the sine of 100. Okay, and I'm just going to use my calculator. I'm going to go 0.5 times 12 times 8 times the sine of 100. I got about a 47.3. That's the area. It's that easy. Just going to use my calculator and go 1/2 12 times 8 times the sine of 100. And that's it. Trig isn't that hard. So I get a 47.3 centimeters squared because it's area, okay? Pretty easy little formula, isn't it? Okay. Example 2. So we can use the same concept to find the area of this pentagon, but what we're going to have is a triangle. So let me go ahead and make a triangle here, and I'm going to highlight my triangle. So I want to find the area of this triangle right there, okay? And what I'm going to need is the central angle. I'm going to need theta, okay? To find theta, because it is a pentagon, we'll go 360 divided by 5, because we're going to have 5 central angles in a full revolution, right? So if I go 360 divided by 5, I get 72 degrees. So I need the central angle, which is 72, okay? So if I put 72 there, then I can use my formula. I don't need to make the right triangle anymore. I don't have to draw the line to get it. I can just go straight to the answer, okay? So normally I would have had to draw the line down here. I would have had to find this height, and then I'd have to find this base. It's a lot of work. However, with the formula, we can go, no, this is so much easier. The area is simply 1/2 10 times 10 times the sine of 72. And I'm just going to go ahead and type that in my calculator. I'm going to go 0.5 times 10 times 10 times the sine of 72. And I get an answer about 47.55. 47.55 centimeters squared. Okay, pretty easy, right, Simon? Oh my goodness, yes, thank you. So multiply that times 5 because there's 5 triangles. Thanks, Simon. Times 5, and I get an answer about 237.7. There we go. That's the answer I want. Centimeters squared. Yeah. I got thrown off for a second. I've got to recover. All right. So law of sines. Here we go. So the law of sines helps us solve triangles. Okay. The area formula gave us area. The law of sines help us solve triangles. Okay. So if we're going to solve a triangle, first of all, we absolutely need. Okay. Write this down. We absolutely must have a pair of opposites, okay? You have to. Opposites means an angle and its opposite side. An opposite means an angle. You need to know an angle and its opposite side. You have to have that. The law of sines will not work unless you have an angle and its opposite side, okay? So, let's figure out what we have. So if I take a look at triangle RED, I've got an angle and I have its opposite side, okay? So I have a pair of opposites, right? I do. I have an angle and its opposite side. Now, I know angle D is 74, so I can find its opposite side, okay? So again, it's opposites, it's opposites. So let me highlight those opposites. So if you have a pair of opposites, you can find an opposite. So I always like to write down what I don't know, okay? Here's my formula. I'm going to go, all right, I'm going to go d over the sine of its angle. So d over the sine of 74 equals 5 over the sine of 38. Okay, I'm going to step back and have you take a look at that, okay? It's really quite simple. It really is. All I'm doing is opposites, opposites. So I'm going d over the sine of its angle equals 5 over the sine of its angle. Side over the sine of its opposite angle. Side over the sine of its opposite angle. That's as easy as this. Now if I want to solve for d, and that's what I want to do, then I'm going to simply multiply that up there, okay? So d will equal 5 times the sine of 74 divided by the sine of 38. Okay, then I'm just going to use my calculator to figure that out. That's pretty easy. So my calculator clear, I'm just going to go 5 sine of 74 divided by sine 38, and I get an answer of about 7.8, okay? So little d is about 7.8. Okay, I'm going to put that into my triangle, okay? So my calculator gave me an answer of 7.8, so I'll put 7.8 there. All right, now, what can I find next? Well, how about angle E, right? I can find angle E pretty easily because we know in a triangle there's 180 degrees, so I can find angle E. I'll find that next. So I know that the angle E is equal to 180 minus my 38 plus my 74, right? And that'll give me the third angle. That's just geometry stuff, right? So I'll go, God bless you, 180 minus my 38 plus my 74. So I get an angle of 68, so angle E is going to equal 68 degrees. Okay, so what I did is I found the opposite side by the law of sines. Found that, I got D, put that in. And then I knew I could find the third angle because all three angles add up to 180. So I got angle E, that was pretty easy. That was 68 degrees. Okay, now, to find little e, okay, listen. You cannot, no Pythagorean theorem, no Pythagorean theorem. Why not? No Pythagorean theorem, why not? It's not a right triangle, right? So we're going to have to use the law of sines again. Does that make sense? Don't use Pythagorean theorem, but we can set up little e over the sine, little e over the sine of 68 will equal 5 over the sine of 38. And I'll step back and let you think about it, okay? So to find little e, I have to have the opposites, right? All comes down to the opposites. So I can go little e over the sine of 68 is going to equal 5 over the sine of 38. Okay? And then I'm just going to multiply this up to get e by itself. And I'll have little e is equal to 5 times the sine of 68 divided by the sine of 38. Okay, and I'm going to go ahead and go 5 sine 68 divided by sine 38. And I get an answer of about 7.5. Okay, that's not too bad. Law of sines is actually easier than the right triangle trig stuff because all you need to know is opposites, right? You don't need to worry about which one's adjacent and hypotenuse and opposite. It's just setting up the opposites, okay? All right, let's turn the page. Okay, now, on the back, it's the same formula, except for it's just written upside down because we want to find the angle, okay? So again, find your opposites. You need to find your opposites. So if we have a pair of opposites, we do. We have a pair of opposites there, right? So you need to find your pair of opposites, okay? And once you find your pair of opposites, then you know that you can use the law of sines. You have to have your opposites first. So if I have this opposites, I can find angle E, right? Because I've got the 20. I can't get T because I don't know enough information, right? But I can get the 20 and the angle E. So let's find the angle E. So I'm going to set up, again, I like to write what I don't know. So I'm going to write the sine of E, of angle E, sine of the angle over its opposite side equals the sine of the angle over its opposite side, okay? Sine of the angle over its opposite side, sine of the angle over its opposite side, okay? Sine of the angle over its opposite side equals the sine of the angle over its opposite side. Okay, then to solve, I'm going to multiply the 20 up there, and I'll have sine of E equals 20 times the sine of 43 over 22, okay? And then I'm going to use my calculator, right? I'm going to use my calculator to get an answer. What do I get? So in my calculator, we're going to go 20 times the sine of 43 divided by 22, and I get a decimal. Well, that can't be my angle, but I need to find the angle, so I have to remember to push the inverse button, right? So I'm going to go sine inverse of that answer, because if I want to find the angle, you have to push the inverse button. So what I did is I pushed the inverse button, and I got an answer about 38.3. So I'm going to go sine inverse of that answer there, whatever that decimal was, and I got a 38.3 degrees. Okay, so circle that and put that back in here. Okay, 38.3 degrees. Okay, now cruise along. What should I find next? Well, angle T, right? Right, angle T, because I can find angle T because I've got 2 of the 3 and I know in a triangle 180 degrees, so I can find angle T next, okay? So I'm just going to go, angle T is easy. To get angle T, I'm going to go angle T is equal to 180 minus my 43 plus my 38.3 degrees, right? And I'm just going to use my calculator to go 180 minus parentheses 43 plus my 38.3, and I get an answer of about 98.7. Angle T is about 98.7 degrees. Okay, we're getting there. We're almost done. Okay, that's angle T. Finally, last but not least, little t, okay? So, here's little t, right? You cannot use Pythagoras theorem. Can't use Pythagoras theorem. Cannot use a squared plus b squared equals c squared because it's not a right triangle, right? So you have to go back and use the law of sines. You've got your opposites, right? In fact, the law of sines is actually easier than even the Pythagoras theorem, I think. So let's set it up. So if I want to find side t, I got to write side t first. Write down what you don't know, so I'm going to go t over the sine of its opposite angle, so over the sine of 98.7 equals opposites. Do your opposites, right? Opposites, so I'll go 22 over the sine of 43, right? To solve for t, I'll multiply that up there, okay? I'll say t is equal to 22 sine of 98.7 divided by sine of 43. I'm going to use my calculator, right, to get the answer. Almost there. So, clear, divide by sine of 43. Yeah. So I'm going to go 22 times the sine of 98.7 divided by sine of 43, and I get an answer about 31.9 degrees. 31, not degrees, about a 31.9, okay, centimeters. That's it. That's the law of sines. So, one more time, what we have to do is this. Set up your opposites, and then it gets quite easy, okay? Formulas are in our notes. There they are. And there they are, okay? Now, we've got a couple of things. You have your cubo-octahedron that we got to get in, and we've got some homework, okay? Oh, I still thank you. Thank Kenzie.